Welcome to the Deep Dive. Ready to go way back in time today
Always.
to explore operating systems.
Yeah.
From the very beginning all the way to today. You've sent us a ton of research on this.
I have been really looking forward to this one.
Me too.
Yeah.
Okay, so to start things off,
Okay.
our sources describe the first computers as having no operating systems,
What?
one user at a time,
Right.
and a whole lot of manual work involved.
Oh, yeah. You had this massive computer all to yourself.
Wow.
But you had to load programs using toggle switches and punch cards.
Really?
And debugging. You're talking deciphering blinking lights on a control panel.
So different from today.
Talk about hands-on computing.
No kidding. So
Yeah.
how did we get from that to what we have today?
Well, it started with symbolic languages,
Okay.
assemblers,
Uh-huh.
and compilers.
Got it.
Those let programmers move away from machine code and use more human-readable instructions.
Makes sense.
It was like going from hand signals to a full-blown language.
A huge step forward.
Exactly. And that paved the way for support code libraries.
Oh, yeah.
Pre-written code for common tasks.
So programmers didn't have to start from scratch every time.
Right. Saved a ton of time.
Our sources mention job queues, too.
Yes.
Was that the computer's first attempt at multitasking?
Not quite multitasking as we know it today. More like a virtual queuing system.
Yeah.
So users could submit programs and the computer would process them one after the other. No constant human intervention needed.
Sounds like automation was creeping in.
Exactly. And you know what grew out of those job queue managers? Runtime libraries.
Runtime libraries.
Yeah. They were key in the shift to full-blown operating systems.
Interesting.
Not only did they handle those job queues,
Right.
but they started taking on more responsibilities.
Like what?
Preventing resource conflicts,
Wow.
implementing security measures.
So they were like the traffic cops of the computer world.
Exactly. And those runtime libraries got more sophisticated. They evolved into programs managing job execution, allocating resources like memory and processing power,
Wow.
enforcing system-wide rules.
Yeah.
They became so crucial that they were loaded first, even before any user programs.
So that's how the modern operating system was born.
Precisely.
So 1956 was a landmark year.
Absolutely.
Our sources point to the creation of GMNAIO,
Right.
the very first true operating system used for real work at General Motors.
Really interesting that a company not known for software was at the forefront.
It is.
Shows how essential operating systems were becoming, even outside of tech.
Then came the 1960s.
Yes.
And IBM
The mainframe giant.
trying to create a single operating system, OS 360, for their entire line of System 360 computers.
A bold vision, one operating system to rule them all.
Ambitious.
Capable of handling everything from scientific calculations to business processing.
A massive undertaking.
And it came with its challenges.
Of course, we found this legendary book, The Mythical Man Month, written by Fred Brooks, a key figure in the OS 360 project.
A must-read for anyone interested in software engineering.
So even with all of IBM's resources,
Mm-hmm.
creating a single operating system was harder than they thought.
Absolutely. The complexity of catering to every use case and hardware configuration led to a family of OS 360 variants,
Okay.
PCP, MFT, and MVT.
Each one tailored to different system sizes and capabilities.
Right.
Seems like this drive for unification keeps clashing with the need for specialized solutions.
Indeed. And that tension continued throughout the history of operating systems.
While IBM was working on OS 360, what was happening with the rest of the mainframe world?
Oh, it was a time of intense competition
Right.
and innovation. Companies like Control Data Corporation, CDC,
Right.
UNIVAC, and Burroughs were all developing their own unique systems, each with its own strengths and quirks.
A fertile ground for experimentation.
Oh, absolutely. Pushing the boundaries of what operating systems could do.
It's wild to think about all these different mainframe operating systems popping up.
It was a really dynamic time.
Our sources mention CDC's Scope and MACE, UNIVAC's EXE family,
Right.
and Burroughs B5000 with its MCP operating system.
Oh, yeah, Burroughs was fascinating.
What made them stand out?
They wrote their entire MCP operating system in a high-level language called ESPOL.
Really?
Yeah.
Wow.
Most operating systems back then were written in assembly language.
Which is much closer to machine code.
Exactly.
So why use a high-level language for something so important? Seems counterintuitive with the hardware limitations back then.
It might seem that way, but they were thinking long-term.
Okay.
High-level languages are easier to understand and maintain, and most importantly,
Yeah.
they're more portable.
Meaning,
You could adapt the operating system to run on different hardware platforms more easily.
so Burroughs was all about flexibility from the get-go.
Precisely. They knew the world of computing was changing fast,
Right, then.
and they wanted an operating system that could keep up.
That's smart.
It was a pioneering move using ESPOL for MCP. Foreshadowed how important portability and maintainability would become in operating system design.
It's amazing how these early innovators were already tackling issues that are still relevant today.
It is. They were way ahead of their time.
Speaking of ahead of their time,
Yeah.
our sources also talk about the emergence of virtual memory.
Oh, virtual memory, a total game changer.
In what way?
It let computers run programs and manage data that were bigger than the physical memory available.
You mean?
Like a magic trick, expanding the computer's memory beyond its physical limits.
So it made it seem like you had more RAM than you actually did.
Exactly.
How did that even work?
A clever combination of hardware and software.
Yeah.
The operating system, working with the hardware, would swap data between the main memory and secondary storage.
Like hard disks.
Right, making it look like the computer had a much larger memory pool.
Genius.
Right.
No wonder it became standard in most modern operating systems, like a virtual expansion pack for your computer's memory.
Exactly.
Sources say Burroughs was a pioneer with virtual memory in their MCP operating system.
They were always pushing the boundaries.
So we have this bustling world of mainframe operating systems, each with its own quirks and innovations.
What's all going on?
What came next in the evolution of operating systems?
Well, while mainframes were the big players, a new kind of computer was emerging. The mini computer.
Mini computers, okay.
Smaller, more affordable, opening up computing to businesses and research institutions that couldn't afford a mainframe.
Made sense.
And these mini computers needed their own operating systems,
Right.
ones tailored to their capabilities.
Our sources mention Digital Equipment Corporation, DEC,
Yes.
a key player in the mini computer world, their PDP series.
Especially the PDP-10 running the Toffee S10 operating system.
Became really popular in universities and research labs.
They were a hit because they offered a balance of power and affordability.
I see.
Powerful enough for serious research, but compact and affordable for smaller organizations. And the Toffee S10 operating system was well regarded for its time-sharing capabilities.
Oh, so multiple users could share the computer's resources at the same time?
Exactly. A big step toward the more interactive and collaborative computing we have today.
Definitely.
But there's another name that keeps coming up.
Let me guess. Unix.
You got it.
Why was Unix so revolutionary?
Unix was developed at Bell Labs in the late 1960s.
Okay.
It marked a huge shift in operating system design, unlike its predecessors.
Often tied to specific hardware.
Right. Unix was written in a new language called C,
C.
which made it highly portable.
When?
It could run on a bunch of different computers without major modifications.
So portability was key to Unix's success.
It was huge, but there's more to it than just that.
Okay.
Unix was also designed with modularity and simplicity in mind.
What do you mean?
It followed this philosophy of do one thing well.
Okay.
Encouraged the creation of small, specialized tools that could be combined to perform complex tasks.
So instead of one massive tool trying to do everything, you had a set of specialized tools that you could mix and match.
Precisely, like a toolbox.
I like that analogy.
And this modular toolbox approach really influenced software development. It's still a guiding principle in many modern operating systems, Linux and MacOS.
Which both have roots in Unix.
Exactly. It's a testament to the power of good design and a clear vision.
So Unix wasn't just a game changer for operating systems,
Yep.
but for software development in general.
Absolutely. Its fingerprints are everywhere, from the command line interface to how we organize files and directories.
That's incredible.
It really is. So we've gone from those massive mainframes with punch cards
Right.
to smaller, more interactive mini computers,
Uh-huh.
and this portable, influential operating system like Unix, all setting the stage for the next big leap in computing,
And that is.
the microcomputer revolution.
Ah, yes. Bringing computing power to the masses.
Exactly. The era of personal computing was about to begin.
Things really took off with the microcomputer revolution.
It's a whole new world.
8-bit processors.
Yeah.
Companies like MOS Technology, Intel, and Zlog battling it out.
It was an exciting time to be in tech, that's for sure.
The Apple II, the Commodore 64.
Right.
So many machines bringing computing power to homes and businesses.
But those early microcomputers had limitations.
Like what?
Limited memory processing power.
So their operating systems had to be super efficient.
Exactly. A lot of them relied on ROM-based basic interpreters.
ROM-based basic interpreters.
Yeah. So instead of a separate operating system, the basic interpreter did double duty.
Okay.
You could write and run programs in BASIC.
Right.
And it also acted as a simple command line interface.
Interesting. Our sources mentioned that a lot of users were still loading programs from cassette tapes.
Oh, yeah, cassette tapes.
I can't imagine the loading times.
It took patience, that's for sure. But it forced developers to be creative, squeezing every bit of performance out of those systems.
Makes sense.
But as technology advanced, so did the demand for better operating systems.
Right. Which brings us to CPM-80.
Developed by Digital Research.
Became the standard for a lot of those early microcomputers.
It was simple, relatively efficient,
Okay.
and most importantly, portable.
There's that word again.
It could run on a variety of machines with 8-bit processors.
Like the Intel 8080 and the Zilog Z80?
Right. That portability was key to its success, especially in such a fragmented market.
Then, of course, we have Microsoft entering the scene.
Yes.
It started with MS-DOS, which evolved into the infamous MS-DOS.
MS-DOS was huge. It was the gateway to computing for so many people.
It was a command line interface, right?
Yes. No fancy graphics, just text commands.
Not exactly user-friendly.
It wasn't always easy to use,
Yep.
but it was powerful and flexible, and it led to a huge amount of software being developed.
But eventually, those command line interfaces started to feel a bit outdated.
Yeah, that black screen with white text.
Right. While MS-DOS was doing its thing, a new kind of user interface was emerging.
Graphical user interfaces, GUI.
GUIs. Offering a more visual, intuitive way to interact with computers.
Exactly. Early GUIs were being developed at places like Xerox, PARC.
Okay.
They didn't take off right away, but they were influential.
They inspired other companies to explore GI-based operating systems.
Exactly, like Apple and Microsoft.
And then came the Macintosh in 1984.
Bringing the GUI to the mainstream.
Icons,
Yes.
windows, mouse pointers.
It made computers so much easier to use, opening them up to a wider audience.
Microsoft was watching.
Oh yeah, they were taking notes. And in 1985, they released Windows 1.0.
Their first attempt at a GI-based operating system.
Exactly. The GUI battle was on.
Apple versus Microsoft. Are there any other contenders?
There were a few. Commodore's Amiga OS.
Known for?
Its advanced graphics and multimedia.
Okay. Anyone else?
Atari's TOS for their ST line of computers.
Right.
And IBM, not wanting to be left behind, developed OS/2.
Also GI-based.
Yes.
Right.
More advanced than MS-DOS.
So much change happening so
Yeah.
fast.
It was a whirlwind of innovation. But as the 90s went on, Microsoft's Windows started to dominate.
With its growing software library.
Right. And aggressive marketing.
Windows became the king of the desktop. But what about mobile? What was going on there?
The mobile world was about to have its own revolution.
Okay.
In the early 90s, companies like Cyan were pushing the limits of mobile computing with their EPC operating system.
Which became Symbian.
Exactly. Symbian was huge in the early smartphone era.
Powering devices from Nokia, Ericsson, and others.
It was designed for those early touchscreen phones with limited resources.
But then in 2007, Apple released the iPhone.
A game changer, just like the Macintosh.
Sleek, intuitive, and with that amazing multi-touch interface.
And running a brand new operating system, iPhone OS, later renamed iOS.
The iPhone and iOS had a huge impact.
Completely reshaped the mobile landscape.
And then Google jumped in.
In 2008, with Android.
Built on a modified Linux kernel.
And open source. Anyone can use and modify it.
Which is why there's so many different Android phones out there.
Exactly. Open source has led to a lot of innovation and diversity in the Android world.
What about Microsoft? Did they try to get in on the mobile action?
They did. With Windows Phone and later Windows 10 Mobile, they struggled to gain market share.
It became a two-horse race.
Android and iOS.
It's amazing how quickly things can change in tech.
It really is. From mainframes to mini computers, PCs, and now smartphones. Each with their own operating system stories.
So where do operating systems go from here? What's next?
That's the big question. But there are a few trends shaping the future.
Like what?
Virtualization is a big one.
Remind me what virtualization is again.
It's the ability to create virtual versions of computers, each with its own operating system, all running on one physical machine.
Like a whole data center in a box.
Exactly. It offers so much flexibility and efficiency, and it's the foundation for cloud computing.
So with everything moving to the cloud, are operating systems becoming less important?
It's a good question. There's a lot of debate about that. Some people think they'll become less visible, just a behind-the-scenes infrastructure layer.
Okay.
Others believe they'll keep evolving, adapting to the demands of this new cloud-based world.
It's exciting to think about how operating systems will continue to shape our digital lives.
It really is. And we can't forget about AI.
Artificial intelligence.
All right. It'll need operating systems that can handle huge amounts of data and complex algorithms.
That's a big challenge.
And then there's quantum computing.
Still in its early stages.
But it'll require a whole new kind of operating system, one designed to harness its power.
Quantum computing. Sounds like something straight out of science fiction.
It does. And who knows what the future holds? And then, of course, there's the constant need for better security and privacy.
Right.
Future operating systems will need to be more robust, resilient, and adaptable to protect our data and our digital lives.
This has been an incredible journey.
It really has.
We've covered so much, from those early computers to the latest advancements.
A whirlwind tour of operating system history.
It's given me a new appreciation for the complexity of these systems.
Me too. And hopefully our listener feels the same way.
Absolutely. So before we wrap up, any final thoughts you'd like to leave with our listener?
As we move towards this future of cloud computing and AI, think about this. Who will control the operating systems that power our digital lives?
That's a big question.
Will we see a shift away from traditional operating systems towards more centralized, cloud-based platforms?
Interesting.
And what will that mean for users and their control over their data and devices?
Those are some thought-provoking questions.
They are. It raises all sorts of issues about control, access, and the future of privacy in a world where operating systems might become invisible but still be everywhere.
It's almost like we're going back to those early days of shared computing resources.
It is, but on a much larger and more complex scale.
Well, on that note, I think we've reached the end of our deep dive into the history of operating systems.
It's been a great
A
journey.
huge thanks to you for being our guide.
It's been my pleasure. And to our listener, thanks for joining us on the deep dive. Keep exploring, keep learning, and keep asking questions.
The world of technology never stops changing.
That's for sure. There's always something new to discover.
Until next time, keep diving deep.